Hi, my name is Mohammed Tarek, and the topic of our lecture is complete binary tree. Complete binary tree will help us understand the important data structure, which is heap data structure. So, before going into the details of heap data structure, it's important to learn and to understand about complete binary tree, and this will help us in understanding the heap data structure. So, let's start the topic now. A complete binary tree is a tree that is completely filled with the possible exception of the bottom level. So what actually happens is if we have a tree, so we need to ensure that every node of that tree should be filled, except with only exception, and that exception is of bottom level. We can have a tree something like this, okay, and as you can see here, internal nodes are filled, and this is a complete binary tree. So here the exception is we have this bottom level not completely filled. But apart from that, its internal nodes are all filled. The bottom level is filled from left to right. So whenever we will try to fill the tree, so we will start from left to right. So if we have something like this, so let's say we have a tree something like this. Now I want to add a new node. I will add here. Okay. I will not add here or here because from left to I have to follow the rule that we'll have to fill the tree from left to right. So new node will be placed here. This is the structure of complete binary tree. As you can see here, the leaf level, the bottom level, sorry, the bottom level is not completely filled, but all the other internal nodes are filled. Recall that such a tree of height h has between 2 raised to power h to 2 raised to power h plus 1 minus 1 nodes. In initial lecture, we have seen how we can get the height of a tree and how we can get the number of nodes within a tree. We have seen the formulas in the previous lecture. You must have know that. The height of such a tree is thus log of n, where n is the number of nodes in the tree. We have seen this also that if we want to know the height of of a tree that we can get using the formula log of n, and n is representing the total number of nodes in that tree. Because the tree is so regular, it can be stored in an array. No pointers are necessary. So this third point says is we can store a tree in an array also. And how we can do that? Let's see. As you can see here, we have a tree, and that tree is in this array from index 1 to index 10. We have stored this tree in an array. So the question here is why I have left this 0 index unfilled. I will answer this question later. For any array element at position I, the left child is at 2 into 1, sorry, 2 into I. The right child is at 2 into I plus 1, and the parent is at I divided by 2. So let's check. So it says that if we have an array of 3, so how I can get the information that which child belongs to which parent and which parent has what are the children of those parents. To get that, we have this formula. So now let's apply this formula on 3, on node number index number 3, node number C, right? So it says the left child is at 2 into I. So I have to multiply by I. I is the index number and index number is 3. 2 3 is the 6. So 6 is the child of C. Okay. 6 is the left child. Right. This is the left child. And if I want to get the right child, so the formula will be 3 plus 1. So it will be 6 plus 1, which is 7. And this will be right child. this will be right child. Okay, so 7 is the right child and 6 is the left child. Now if I want to know the parent of C, so I can use this formula, I divided by 2. So 3 divided by 2, I will get something 1 point something, right? So I will take only the integer value, and the parent of C is 1. So in this way, I can know that a node has the position, the index position. I can get the index position of the left child or the right child of any node, and I can also get the index position of the parent. For suppose if I want to get the parent of 6, so what I can do, 6 divided by 2, so it will be 3, and we know that 3 is the parent of 6. So now if I want to use 0, let's suppose if I have 0 and I have element, let's suppose A here, let's here we have A, here we have B, and here we have C, right? So if I want to get the childrens of A, right? If I want to get the childrens of A, the formula is 2 into I. So it's equal to 2 into 0, and the answer is 0. And if I want to get the children or and the if I want to get the right child, I will be then 2 into I plus 1. So it will be 2 into 0 plus 1. So the answer is 1. So as you can see, the left child, it is the left child, and this is the right child. For left and right child, I do not have the correct information because the left child is at index 1, is 1, and the right child is at index 2. But for the left child, I am getting 0, which is not correct. The 0 is the position of the root node, which is the A, right? So that's why I have left this blank. I'm not using this index number. I'm starting from 1, index number 1. As you can see here, using this formula, I can get the I can get the children of node B, and the children are D and E. In the same way, the children for C are E and F, and for D, I have H and I. So in this way, I can maintain an array of a tree. I can maintain the nodes of a tree in an array form. So if we traverse in level order technique, if we use the level order traversal, so what is the level order traversal actually? So the level order traversal is something like this. So we traverse using the levels. So this is level 0, this is level 1, level 2, and level 3. So what level order traversal says is, first we will print the elements on node on level 0, which is A, right? Then we will traverse on level 2 and we will print elements from left to right. So then it will be B and then C. For second level, we will again print starting from left going towards right. So D, A, F, and G. So in this way, so here the way we are maintaining these elements in an array is actually a level order traversal. So every element, if as you can see, the first element is of level 0, then these two elements 2 and 3, the elements B and C are of level 1, and elements D, E, F, G are of level 2. This is level 1, this is level 0, and H, I, J, this is level 3, right? This is how we have maintained the level order traversal. I want to thank especially Dr. Suhail Aslam for the preparation of this lecture. Thank you.